Dear friends, welcome to STEM Scholar. From the lower classes itself, we will study about light. And from there onwards, we are studying that light is propagating in a straight line. That is a rectilinear propagation of light. Light is traveling in a straight line. This was the basis of Newton's theory, corpuscular theory. In corpuscular theory, he was proposing that light was traveling in a straight line. So is it exactly correct? Is it light travels exactly the straight line? Now certain modifications are there. See an interesting thing. So if light is traveling in a straight line, so if it is traveling in a straight line and sometimes it bends, if it is traveling around Earth or around any planet, it bends in the atmosphere. We are saying, why it bends in the atmosphere? See, if there is a light, if there is a straight line light, if there is an effect of gravity, due to the effect of gravity, light bends. So we can say that to an extent light bends due to the effect of gravity. That is, the modern studies are going in that way. And Newton could successfully explain reflection and refraction. And he was saying that light is traveling more speed in denser medium. Light was traveling greater in denser medium than rarer medium. That was the concept of Newton. Then Foucault, the scientist Foucault, proved it is wrong. Light is not traveling faster in denser medium. So then came our wave theory. Huygens put forward a theory. That theory is known as Huygens theory. According to Huygens theory, he was proposing that he could firmly explain reflection, refraction, interference, and many other phenomena like polarization, etc. So he was saying that light is no longer a corpuscle alone, no longer travels in straight line. It has got some wave nature also. Let us discuss something about the wave nature of light. So let us discuss about the Huygens theory today. The Huygens theory. Huygens Principle. Huygens Principle. Let us discuss about Huygens Principle. Before going to Huygens Principle, let us imagine a situation. Take the case of a still pond, a calm pond surface. On that pond surface, we are dropping a stone. So automatically the surface gets disturbed. And what is happening to the surface? There may be formation of waves. Waves are generated like this. There may be concentric circles. There may be concentric circles around that disturbance. And waves are coming out, are emanating from that particular source of disturbance. So concentric circles everywhere. Now we can say that at all these points, this is the center of the disturbance, and we are drawing certain lines. This is the distance of the first radius of the first circle. Around this circle, we can say that all the particles are in same state of vibration around this circle. Then this is the distance. This much distance is the radius of the second circle, and around this circle, on that particular surface, circular surface, all the particles are in same state of vibration, or we can say that the particles are in same phase. And around this circle also, the particles are in same phase, are in constant phase. So what do you call that thing? See, we are taking a source, a point source of disturbance, and the rays are emanating from it. The rays are coming out. This is the rays are coming out. This is a ray diagram of the rays coming out from this particular point. And we can say that at particular distance, we are taking from a particular distance, r distance, we are taking everywhere r distance. On all these points, it is seen that on all these points, the particles are in same state of vibration. So what we are doing now, we are connecting these lines. We are connecting these lines. We are connecting these lines, or we are connecting the locus. We are finding the locus of all these points. The locus of all these points, which are in the same state of vibration, is known as wavefront. It is known as wavefront. So we have introduced a new concept. The new concept is wavefront. Wavefront is nothing but, it is the locus of all the points on a surface, on a particular surface, which are in the same state of vibration. Again, if you are taking another situation, and if you are finding the locus, again the locus we are finding. Again we have drawn a locus. This is the first wavefront and this is the second wavefront. There is a constant difference. There is a constant distance. The distance to the wavefront is same on the same surface. To this particular point, to this wavefront also, the distance is same. So this is wavefront. Wavefront is nothing but the locus of all the points on a surface which are in the same state of vibration. See, so this is our wavefront. This is a circular wavefront. Waves emanating from a pond can be taken as a spherical wavefront. Spherical wavefront. Spherical wavefront. So this is a point source. A point source is producing a spherical wavefront. Suppose we have a line of charge, a line of disturbance, like this. A wave is like this. A source of wave is like this. A straight line. If it is a straight line, then waves may be emanating like this. Here also, waves may be emanating like this. So, what will be the shape of the wavefront? This is a line source. This is a line source, a straight line source. For a straight line source, what will be the wavefront? So, we are finding the locus. Here also we are finding the locus. We are drawing like this. So, here we got a cylindrical wavefront. This is a cylindrical wavefront. So for a point source, this is a spherical wavefront. For a straight line source, we have a cylindrical wavefront. Suppose the source is far away. The source is very much away from us. It is like this. It is very much away from us. Its source is very much away. What will be the shape of the wavefront? The shape of the wavefront will be like this. It will be a plane wavefront. Plane wavefront. So we have introduced a concept. That concept is wavefront. So, and what is the energy transmission in the case of spherical wavefront? See, this is the point of disturbance. From the point of disturbance, waves are emanating. The spherical wavefronts are emanating, are coming out. If that is the situation, then what will be the direction of energy propagation? We know that wave motion is in the form of energy propagation. Energy is transferred from one place to another place. If the wavefront is in circular shape, energy propagation is perpendicular to it. Energy propagation is perpendicular to the wavefront, the shape of the wavefront. Now, what will be the ray diagram then? Is there any connection between the ray diagram and spherical wavefront or wavefront? This is our rays. These are our rays. And see, at any point, if you want to draw a ray diagram to a spherical wavefront or a wavefront is normal to the wavefront. A ray is A ray is normal to the wavefront. So that is ray. Now, we are coming to our point. What is Huygens principle? Let's come to the point. We are discussing about Huygens principle. Suppose we have a source. From this source, rays are emanating. This is our rays. This is our rays. And one particular point we are taking. Same distance. This is point O. O is the origin. And same distance. Through same distance, we are drawing a locus. We are drawing a locus. So here we have got a wavefront. This is primary wavefront. This is primary wavefront. Now, what is the Huygens principle? Huygens principle states that every point on this primary wavefront, take any point on this primary wavefront, maybe this point, whatever may be the point, you take any point on the primary wavefront, every point on the primary wavefront acts as a source for secondary wavefront. It's as a source for secondary wavelets. Secondary wavelets. See, we know that light is moving with a velocity v. If light is moving with a velocity v, and we want to find out after this wavefront, this is primary wavefront, we want to find out a new wavefront after this wavefront. We want to find out a new wavefront after the primary wavefront. Where shall we get a new wavefront after this? At a particular time t. At a particular time. So we know that distance is velocity into time. Velocity into time is distance. So this much distance. Taking this much distance, we know the velocity, we know the time after which we want the wavefront. So it is vt. So taking vt as radius, taking vt, this point, we are taking this one, vt as radius. We are drawing a circle. Again vt, taking vt as radius, we are drawing a circle. Again vt, this point, taking this point as a radius, this point as a source, we are drawing a circle. So we have circles like this. We have circles like this. Now what we are doing, we want to get the new wavefront. How will you get the new wavefront? So we are, again, tangent is drawn. The tangent to all these circles, or we are finding an envelope. We are drawing an envelope to these circles. If we are drawing an envelope to these circles, we are obtaining a new wavefront. This is our secondary wavefront. So how did you get a secondary wavefront? So this is our primary wavefront. Each point on the primary wavefront is acting as a source for secondary wavelets. Okay, so we want a new wavefront at a distance vt. We want to find out a new wavefront at a distance vt at a time t. So take vt as radius. We are drawing circles, and finally, what we are doing? We are finding an envelope. We are drawing an envelope for these small circles. So the envelope is getting as secondary wavefront. See, this is Huygens principle. So Huygens principle says that every point on the primary wavefront is acting as a source for secondary wavelets, and the envelope of it gives the new wavefront after a particular time, which are moving in the same direction, which are moving in the same speed as the original wave. This is Huygens principle. And one more specialty is that we have taken forward path, in forward direction. In forward direction, we have drawn an envelope. See, there is a drawback for it. Here, this is the backward direction. We can also draw backwards. In the backward direction also we can draw an envelope. So this is the production of back waves. So there is back waves. Actually, back waves are not at all existing. Huygens tried to explain the effect of back waves, but that was not satisfactory. So this is one of the drawback of Huygens principle, that is back waves. Okay, so this is about Huygens principle. It gives the new wavefront or the shape of the wavefront after a particular time. So it is having an importance in the wave optics. So we have discussed about wavefront and Huygens principle. Hope you understood it. In the next class we will come with a new topic. Do write your suggestions. Thank you.